Hello.
Hello.
Hello, Mr. Ryan. All right?
Hey God, the camera thing is broken.
No, not yet. Okay, come on. Can you turn around, please? Okay. We talk about the uncrossed lines. Okay, uncrossed lines. So we want to find out the maximum numbers.
Pairs.
Yeah, the maximum number of lines. Okay. So this is problem is actually the longest common
Multiple.
substring or subsequent.
Sub. Which one doesn't continue?
Okay, so which one?
Which one is? I think is it substrate? Is it?
Subsequence.
Yeah, longest common subsequence, because look, we are trying to find out the longest subsequence between two strings, right? It's the same problem, right? So
LCS.
yeah, LCS. We want to find out the LCS. It's basically longest common subsequence. We talk about the top-down dynamic programming. Define dpij, right? We can calculate from right to the left or left to the right. Let's do it from right to the left. If I smaller than 0 or j smaller than 0, then we return 0, right? And otherwise, okay, if ai equal bj, if ai and bj are the same, right? If they are same, then I can put a line between. Okay, so the answer will be dp I minus 1, j minus 1 plus 1, right? Because we found a match here. Otherwise, if not, then we return the maximum. There are two cases. Maximum of dp I minus 1j or dp ij minus 1, right? dp I minus 1j or dp ij minus 1. Top-down dynamic programming. Memorization, cache. We can implement a cache ourselves. What's cache? This word mean? Have I ever talked about this meaning of
Yes.
this English word? What does it mean?
It means money.
Not like cash. This is a piece of memory computer to store the data for faster retrieval data. Let's just give an example. To compute the sum from 1 to 100. We all know it's 50-50, right? Let's say the computer does a very stupid way by counting, right? It took the computers a long time to calculate the sum from 1 to 100, okay? Yeah?
It probably won't take 100 seconds.
I know. Later, right? You ask the computer again, what's the sum? What's the sum from 1 to 100? The computer does not need to do that work again, right? And the computer can just retrieve the data. So the first time it calculates it, the computer put this in a piece of memory. This is cache. And then later you ask the computer, what's the sum? And the computer will go back to check, okay? Have I ever calculated the sum? Yes, then I just simply give you 50-50 without thinking, without even doing the further work. Okay, this is cache. The same thing.
5,050.
Why do you need to put at cache?
Okay, that's a good question. At is a keyword. It's at cache means the attributes. Okay, so
What happens if
for
you
the-
don't put at?
then there will be a syntax error. The Python code cannot be run. The computer will say, okay, I don't understand why you put a cache without the add. Add is a special keyword to say, okay, I want to decorate this function. This is kind of attribute with this. Okay, so it means that for any parameters I and j, the computer will memorize it. So for example, like dp02, right? You calculate somehow like answer is 3. So the next time you're calling this function with 02, the same parameters, the computer will not run this code. Instead, the computer will look for the 02 in the cache and then say, okay, previously 5 minutes ago, you asked me to compute the dp02. At that time, I calculate the answer is 3. Now you ask me again, so I don't need to spend time working out the value of dp02. Then I simply present you the answer, which is 3. Okay? We talk about the bottom up, the value here. Yeah, we filling the numbers from top to the bottom, from the left to the right. Okay? Bottom up dynamic programming. We're going to optimize the bottom up dynamic programming. Longest common subsequence. define dp a b. Okay, n1 equals the length a, n2 equals the length b. Remember we added the extra bit, right? Added the extra bit +1 +1. So the answer equals 0 times n1, n2. n1 is the rows, n2 is the column. So this is n2 for underscore in range n1. So here, this is n1, this is n2. And then we add the extra bit 0, right? 0. Okay, so we basically bottom-up dynamic programming is that we're trying to compute the values in these tables from from first row to the last row, and the answer is here, right? This is the answer. So we want to find out this value, answer. The bottom-up is calculating from the first row, first column, until we get this point. This is the answer. The top-down is that we want to calculate this value, so it possibly depends on this value, this value, this value. Right? And in order to calculate this value, it possibly needs this value, this value, this value, until it recursively traces back to the first one. So it's the two different directions, right?
What do you mean by possibly?
Possibly, yes, possibly. Remember this one. If AI equals bj, then it only needs the I minus 1, j minus 1. So if AI equals bj, then it only needs this value. If not equal, it needs these two values, and the maximum value of it is this value, okay? Does it make sense? Yes? This is the dynamic programming equation. Okay? And then for I in range, we start from 1, the second value, because we added extra bit to n1, right? n1. n1 plus 1. The last index is n1. For j in range, start from the second value, 1 to n2 plus 1. This is the columns. This is the first dimension is the arrays. Then if dpi minus 1, j minus 1, right? Because it starts from 1, we added the extra zeros. First index would be I minus 1, start from the 0. If ai minus 1 equals, if ai minus 1 equals bj minus 1, then dpij equals dpi minus 1, j minus 1 plus 1, right? As dpij equals the maximum, which is dpi minus 1, j, and dpij minus 1. The answer we want to get is return answer minus 1, which is the bottom right corner. From right to the left. From the left to right is similar, right? Instead of minus 1, we plus 1. This number only depends on possibly 3 values, yeah? This value, this value, this value. So it means that this value, if I want to calculate this value, I only need to know the rows above it, right? I don't need these rows, right? I want to calculate this value. I only need this value, or this value, right? I don't need any of these values. I don't need any of those. I just need the rows, the previous row. So it means that I don't need to save. I don't need to save this. This is the 2-dimensional array. I don't need to save it. So this is the 2-dimensional array, right? It allocates this 2-dimensional array, a table, which it could be very big. But during the calculation, I only need one values, one row, one single dimension above it, right? I don't need this entire table, am I right?
Yes.
We can do this optimization. Instead, so here, I can just do this. Answer equals 0 times n2. And that's it. Now this is one dimension. And then the previous one, I need to save a copy, right? I need to save the previous row, right? So the previous one equals answer. We make a deep copy. Deep copy. Okay? Deep copy. Or we can do this copy dot deep copy. What's deep copy? What's shallow copy? Any idea? What's the difference between copy and deep copy and shallow copy?
I think you
Shallow copy
I think you said
for decopy copy more.
I think you said that for the shallow copy is like the values are like alien whatever,
Yes, alias.
alias, and then the other one is just
Aliens.
the same, yeah.
Alias, not aliens. Okay, aliens is
Aliens have arrived.
UFO, right? Those aliens, right? What's UFO? You understand?
Unidentified flying
Flying
object.
Yeah, aliens could be in the UFO, but not like it's alias. Alias means that it's just a name, right? Deep copy. Okay, deep copy. A equals 1, 2, 3. B equals A. This is shadow copy. B is just an alias of A. So if I change the B0 to 0, then A will also be changed, right? This is alias, shadow copy. But if I do this A, this is the deep copy, meaning B is a separate copy of A. Also, we can use copy dot decopy, okay? So we copy that, then we can get rid of first dimension, right? First dimension. We need to change this 2-dimensional to 1-dimensional. I is ith row. dpi minus 1 is the previous row. We want to retrieve this value and this value and this value, right? We get rid of first dimension, right? And then this is dpj. The previous row, if it's in previous row, then we need to change it to previous. If it's previous row, then we change it to previous. And then this one will be, we just simply get rid of the first dimension, dpij minus 1. And that's it. After each iteration, we need to make a copy. Previous one equals dp, the current row, okay? So basically, previous is the previous row, dp is the current row, right? Each iteration, after each iteration, the previous will be a copy of the current row, and current row, current row, current row. So we'll be able to access the previous row, right? Here, this is the deep copy. And then at the end, we return dp minus 1. Okay? We managed to convert the 2-dimensional to 1-dimensional. Okay, so the space complexity is O n, right? N is the columns. The time complexity is still O n1, n2. Space complexity is O n2. If n1 equals 100, if n2 equals 10,000, one array is 100 elements. Another array is 10,000 elements. The time complexity is O(n)(1) and 2. The space complexity is O(n)(2). So which array should we choose as the columns? Is this n1? Is this n1? Which one is n1? One of dimension is n1, one dimension is n2. So what I'm saying is that n1 is 100, n2 is 10,000. So which one should be n2? Is this n2
Yes.
or is this n2?
No.
Why? Why?
Because one is longer.
Space complexity is O(n)(2), right? So we want to reduce this because n2 is bigger, so it's better we use the n1, right? So we can just swap around the arrays. Yeah, because the space complexity is O(n)(2). So space complexity is this, right? This. We squeeze the table into one-dimensional array, which is n2, 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 n2. So it's better I use the shorter version of it, right? So if A is, very long, B is very short, then we use the B, array B as the columns.
Yes.
The time complexity is still the same, but the space complexity, we squeeze the space from 2D to 1D, okay? That's it for today, bye-bye.
Bye.
Bye-bye.